Okay, let's solve this pretty easy equation. Cosine of theta equals negative 0.2. So to do so, we already have the cosine on one side all by itself, so we don't have to do any rearranging or solving on that. The next thing I'm going to go ahead and suggest is we want to get theta out from inside of the cosine. To do so, let's apply a cosine inverse or arccosine to both sides. Okay, so on the left-hand side and the right-hand side, apply that arccosine. Because we've composed together the cosine inverse and the cosine, we're going to get some nice simplifying down with inverse functions. This is going to give us theta. And then what I'm going to do is go ahead and put this in our calculator. I'm going to be in radian mode in my calculator, and I got this to be 1.77215, and it just keeps going. Next thing to think about is that got returned to us, which quadrant is that angle in? So to think about that, I like this phrase, all students take calculus. All right, and what this helps us remember is which quadrant each one of these angles is going to be positive in. So our initial equation had cosine of theta equaling a negative value. So cosine was negative. Let's think about which quadrant that could be in. Now it's not in the first quadrant because all of the sine, cosine, and tangent are positive there. The second quadrant, only sine is positive, third, tangent is positive, and fourth, cosine is positive. Now, we had cosine equals a negative, so that eliminates the fourth quadrant as well. So we can have a cosine of theta being negative in either the second or the third quadrants. All right, this angle that we got is between half of a pi and 1 pi. All right, you may think of 1 pi as about 3.14. Half of a pi is about 1.5-ish, a little bit over 5. But ours turned out being 1.7. So that tells us that the angle that we just got returned is in the second quadrant. All right, so from pi, our angle that we just found, this 1.77215, fits into the second quadrant. All right, so that's good. The other thing that we want to do is we want to also find what angle do we get in the third quadrant that also satisfies this cosine of that angle equals a negative value. So this is our quadrant 2 value. To get a quadrant 3 value, what we want to do is next find the reference angle. So the reference angle, we're going to start with the angle that we found, that 1.77, and we're going to draw it to the x-axis. Now I'm going to go ahead and label this as theta bar as being our reference angle. So reference angle theta bar, we have to compute that. Well, what we're going to do is we're going to start with, it's made up of these two side lengths. We're going to start with the bigger of the two, which is pi. And if we subtract off that smaller side length, which is that 1.77215, that'll be our reference angle. So the reference angle, theta bar, is going to be approximately 1.36944 using pi minus that 1.77. All right, so how do we use that and place it into the third quadrant? Well, how it's going to work is we're going to start with pi in the third quadrant and then extend that past pi by that reference angle, theta bar. So our angle in the third quadrant is going to start with pi, and I'll go ahead and say it's theta is going to be an additional angle here. It's going to be pi plus that reference angle. So in our case, theta is going to be pi plus that 1.36944 that we just calculated over on the right-hand side. So this is going to work out to be right around 4.5110. However, we haven't quite represented all of the possible solutions. We found them in the first time around the circle, right, between 0 and 2 pi, but we haven't found them the general solution. So to do that, what we want to do is to the end of each one of these, we're going to add the period of cosine, which is 2 pi, multiplied by some integer k. So this plus 2 pi times some integer k. So k is an integer. All right, so we got solutions in the second quadrant, solutions represented in the third quadrant, and by adding that 2 pi times k, this is a periodic function, right? Cosine is, so it repeats itself every single time you go around the circle in either the positive direction or the negative direction. So those are all of the possible solutions. I know we've got decimals, which is a little awkward. It's just how it goes on some of these. Do your best as you're working them. I like drawing the pictures, seeing exactly where the reference angle is, kind of get a feel for that, and then put it in the appropriate quadrant. Based on that, all students take calculus. Hope this helps out. Good luck as you're working through solving trigonometric equations.